Hi, this is the read aloud for Chapter 4, Lesson 1, Forces in Earth's Crust. How does stress change Earth's crust? How do faults form? And how does plate movement create new landforms? This is Mount Everest. It's in the Himalayas. It's the highest mountain on Earth. Climbers who reach the peak stand 8,850 meters above sea level. You might think that mountains never change, but forces inside Earth push Mount Everest at least several millimeters higher each year. Over time, Earth's forces slowly but constantly lift, stretch, bend, and break Earth's crust in dramatic ways. How does stress change Earth's crust? Rocks are hard and stiff, but the movement of Earth's plates can create strong forces that slowly bend or fold many rocks, like a caramel candy bar. Like the candy bar, some rocks may only bend and stretch when a strong force is first applied to them, but beyond a certain limit, all rocks in Earth's brittle upper crust will break. Forces created by plate movement are examples of stress. Stress is a force that acts on a rock to change its shape or volume. Geologists often express stress as force per unit area. Because stress increases as force increases, stress adds energy to the rock. The energy is stored in the rock until the rock changes shape or breaks. Page 121. Three kinds of stress can occur in the crust: tension, compression, and shearing. Tension, compression, and shearing work over millions of years to change the shape and volume of rock. Most changes in the crust occur only very slowly, so that you cannot directly observe the crust bending, stretching, or breaking. Figure 1 shows three types of stress. Tension. Rock in the crust can be stretched so that it becomes thinner in the middle. This process can make rock seem to act like a piece of warm bubble gum. The stress pulls that force the stress force that pulls on the crust and thins rock in the middle is called tension. Tension occurs where two plates pull apart. You can think of this as bubble gum or silly putty or clay. Compression. One plate pushing against another plate can squeeze rock like a giant trash compactor. It compresses it. The stress force that squeezes rock until it folds or breaks is called compression. Compression occurs where two plates come together. So the arrows on this one, you can draw two arrows pointing in, so they're squeezing it together. Shearing, stress that pushes a mass rock in two opposite directions, is called shearing. Shearing can cause rock to break and slip apart or change its shape. Shearing occurs where two plates slip past each other. So one arrow is going to be pointing that way and one arrow is going to be pointing this way on your paper. You can fill those in. We're going to turn to page 122. How do faults form? You've heard me say before, it's not my fault. I didn't mean to break it. So a fault is a break. Recall that a fault is a break in the rock of the crust where rock surfaces slip past each other. Most faults occur along plate boundaries where the forces of plate motion push or pull the crust so that the crust breaks. When enough stress builds up in the rock breaks, creating a fault. There are three main types of faults: a normal fault, a reverse fault, and a strike-slip fault. Think of if you have maybe a marble table or a piece of marble, and there's a small crack in there, and you don't know how it's going to end up cracking, but you know that there's a crease in there. So think of those as two separate plates of Earth's crust, and that when they do finally break or move past each other, they're going to create a fault. So a normal fault is one that you can find in the Rio Grande River. It flows through a wide valley in New Mexico. Here, tension has pulled apart two pieces of Earth's crust, forming the valley. Where rock is pulled apart by tension, remember, pulled apart like silly putty, in Earth's crust, normal faults form. In a normal fault, the fault cuts through rock at an angle so that one block sits over the fault, while the other block lies under the fault. This is probably a good example. So either way, one's going to go up and one's going to go down. They're not going to break straight. They're going to break on a diagonal. The block of the rock that sits over the fault is called the hanging wall. So this is going to be the hanging wall. And the rock that lies under the fault is going to be called the foot wall. The diagram of the normal fault in figure 2 will show that. So they're showing a normal fault, which is this hanging wall will slide down and the foot wall will stay up. This is the opposite, where this big one, the hanging wall moves up. So they call this one a normal fault and this is a reverse fault. So typically what's going to happen is this one looks like it's going to go down, and this one, it actually moves up. Page 123. A reverse fault is of the northern Rocky Mountains. They rise above the western United States and Canada. These mountains were gradually lifted up over time by movement along reverse faults. A reverse fault has the same structure as a normal fault, but the blocks move in the reverse direction. That is that the hanging wall, the one with the bigger hook on top, moves up, and the foot wall, the one that looks like a foot, moves down. Figure 2 shows a reverse fault. Reverse faults form where compression, so pressure, pushes the rocks of the earth together. A strike slip fault over here is the one that we're going to watch a movie on next week. The hilly plains in Southern California are split by the San Andreas Fault. San Andreas, California, shown in figure 2. Here, shearing has produced a strike slip fault. In a strike slip fault, the rocks on either side of the fault slip past each other sideways. So you can see how they're shifting this way. And with a little up and down motion. A strike slip fault that forms a boundary between two places called a transform boundary. The San Andreas Fault is an example of a transform boundary. So they're hanging there. Page 124 goes a little bit further. How does plate movement create new land? We're going to look at folding Earth's crust and anticlines and synclines and folding. And then we're going to talk about stretching Earth's crust and uplifting Earth's crust. This is a little bit of a long chapter, so I apologize. How does plate movement create new landforms? Most changes in the crust occur so slowly that they cannot be observed directly. But what if you could speed up time so that 1 billion years pass by in minutes? Then you could watch the movement of Earth's plates fold, stretch, and uplift the crust over wide areas. Over millions of years, the forces of plate movement can change a flat plane into features such as anticlines and synclines, folded mountains, fault block mountains, and plateaus. Folding Earth's crust. Have you ever skidded on a rug and wrinkled it up as your feet push it across the floor? Sometimes plate movements can cause Earth's crust to fold, much like a rug. Then, rocks stressed by compression may bend without breaking. How folds form. Folds are bends in rocks that form when compression shortens and thickens Earth's crust. A fold can be a few centimeters across hundreds of kilometers wide. Figure 3 shows folds in rocks that are exposed when a road was cut through a hillside in California. Very interesting view. If they did not cut through this land, you would not be able to see that. In anticline and synclines, geologists use the terms anticline and syncline to describe upward and downward folds in a rock. A fold in a rock that bends upward in an arc is an anticline, so they both start with A. You can remember it that way. A fold in rock that bends downward, forms a V shape, is a syncline. Maybe the V shape and the syncline, the Y in there, they might go together in your brain, but that's how you remember it. The anticline goes on an arc, so it goes up, and the syncline is a V shape, it goes down. Anticlines and synclines are found in many places where compression forces have folded the crust. The Central Appalachian Mountains in Pennsylvania are folded mountains made up of anticlines and synclines. So it's going to look like this one. So the upward one is going to be the anticline. The downward one, this V shape, is going to be the syncline. You can write those in right there. And just remember, they're getting pushed together, so you're going to put 2 arrows facing in that way. I'll give you a minute to do that. How folded mountains form. The collision of 2 plates can cause compression and folding of the crust over a wide area. Folding produced some of the world's largest mountain ranges. The Himalayas in Asia and the Alps in Europe formed when pieces of crust folded during the collision of 2 plates. These mountains formed over millions of years. Page 26. Stretching Earth's crust. If you've traveled by car from Salt Lake City to Los Angeles, you would cross the Great Basin. This region contains many mountains separated by broad valleys or basins. The mountains form from tension in Earth's crust that cause faulting. Such mountains are called fault block mountains. How do fault block mountains form? Where 2 plates move away from each other. So it looks like a double here, and that's kind of what they're talking about. It's breaking in 2 spots. Suppose 2 normal faults cause valleys to drop down on either side of a block of rock. This process is shown in figure 5. As the hanging wall of each normal fault slips downward, the block in between now stands above the surrounding area, forming a fault block mountain. We're not going to fill all of these little charts in, but if you look at the key on the bottom, the red is the movement along the fault. So one's going up and this is going down. And then forces deforming the crust are pulling them out. And 27. Uplifting Earth's crust. The forces that rise mountains can also uplift or rise plateaus. A plateau, if you can remember from a previous chapter, is a large area of flat, elevated land high above sea level. Think of the Lion King. Some plateaus form when forces in Earth's crust push up a large flat block of rock, like a fancy sandwich. A plateau consists of many different flat layers and is wider than it is tall. Forces deforming the crust uplifted the Colorado Plateau and the Four Corners region of Arizona, Utah, Colorado, and New Mexico. Figure 6 shows one part of the plateau in northern Arizona. So this is the large flat land up here. If there's anything in this chapter or place that they talk about that you would like to look up on Google or research on your own, please feel free to do so. Scholastic is a great website, and also Discovery Education is a great website, National Geographic. So feel free to do some extra research, and I will see you guys soon.